All right, this is chapter 16, question 50, part F. And so once again, they're asking you to start with bromocyclohexane and get to this final product. What are the steps in between here? So this one, there is a lot of steps. So you're asking, is there a simpler way? And a lot of times in these longer synthesis problems, there definitely could be other ways to do it that the book didn't go through in their solution. And so if you did it a different way, it may be right, and that doesn't mean that it doesn't mean that your way is wrong if you didn't do it the exact way of the book. But the way the book did it is sort of it does take a lot of steps to get through this. So one way, sometimes in synthesis, I think that it helps to start working backwards from your product and think, what did that come from? And then look back at your reactant and say, how can I get to that? Instead of just looking straight across, because just looking at these two, it's pretty hard right now to think, like, how did we get there? But the one thing you do want to look at, so you're starting at with bromocyclohexane, and what are we doing? We're adding some carbons, and instead of a bromine, we have this chlorine here. And so we know we're going to have to use some reaction that you know that is going to make a new carbon-carbon double bond. So just thinking about working backwards, so let's think. We have this. And so that's what this sort of type of arrow right here is sort of a retrosynthesis arrow, meaning working backwards. But I can visualize one of the first reactions that you learned in OChem 1 was just adding like HBr across a double bond. That's like one of the first reactions that you learned. This goes to the carbocation. And so that's what, when I'm looking at this, I'm like, okay, I have this chlorine here that could have just been, if you have this and if you had added HCl to it, you would have gotten that. And so that's sort of the first thing that I'm thinking. And then, okay, now we've got this double bond here. How are we going to add more carbons to this? And so now I've already looked at the solution, so it's harder to talk through how I would retrosynthesize this because I've already sort of looked at it. Oops. So basically, the book just moves this double bond here. And now I'm looking at this compound here and thinking we were just using the Wittig reaction and we were doing something similar to this. And so you definitely could use the Wittig reaction now to produce something that looks like this. And since we're starting with bromocyclohexane, we could definitely make a phosphonium ylide out of that and eventually get to here. So I'll work through that way because I think it's a little bit easier, and then I can also talk through the way the book did it. So let's think we're gonna make this into a phosphonium ylide, which does take a couple steps. Add the butyllithium. And I should have just erased what I said we needed to get to. But if you can remember, it's also in the book. This is sort of what that spot where I was like, okay, if we can get to this, then we can finally get to our product. And so how are we going to get from this to this? What are we going to need to add? So we can sort of just count the carbons. So same thing as before. We've already got these 1, 2, 3, 4, 5, 6 carbons. So all that we need to add from the aldehyde or ketone is just 2. And so that tells you this is going to be an aldehyde. There's your 2 carbons. So just add this aldehyde, then you're going to get to that. Now we know we can get to I guess, yeah, this is 2 steps. So first, they're sort of drawing out 2 steps. I guess you could draw it in 2 steps, but basically just adding a proton across this double bond is going to produce a carbocation, similarly to up here, like the first step of this reaction. If you can remember all the way back to OChem 1, is just taking the hydrogen there, and then you get a carbocation. And so that's exactly what's happening down here in this step. You can think this double bond is just sort of grabbing that proton, and then you have your carbocation left on the most substituted carbon. And then just do an elimination reaction. What did the book use? I don't really know what that means. The book wrote this in their solutions, I believe. I don't really know what that means, but basically any nucleophile is going to be able to just pull off this hydrogen here, and those electrons will swing in, and that's how you get to this double bond here. And then remember, we already talked about this last step. We can just simply add HCl across this double bond, and you're going to have your product. So that's one way differently you could have done it. I'll quickly go through how the book does it, just so you can, if you're confused about what's happening in the solutions. So there, instead of forming a phosphonium ylide and going the Wittig reaction, they're going to form a Grignard and do some reactions with that. And so basically to form the Grignard, you need magnesium and diethyl ether. Now you have your Grignard reagent. So here they're adding in those extra 2 carbons. If you remember, a Grignard reagent and an aldehyde is going to form an alcohol. And so basically in a Grignard, this carbon gets to act like a nucleophile. What happens is it's attacking there, the electrons are swinging up. And so you now have a bond between the carbon of the cyclohexane and the carbonyl carbon. That's here and here. There was still this methyl attached, that's why there's still a methyl there, and those just swung up. Okay, next they're going to do an elimination reaction. This is also from OChem 1. This would be E1 elimination. That's going to eliminate your alcohol right there. And it forms a double bond right here because this is the most stable double bond. It wouldn't form, I'll draw it really quickly. It's not going to form the double bond here because this double bond is less substituted than this one. So this is the main product, that major product it's going to form. Okay, and then from here, it's the same steps as up here. So once we get to sort of this product here, those are the same, and then it would just be the same exact steps after that. So I hope that helps you sort of understand what's going on here. And this was the original question they were asking.